All right. I still have waiting for diffusion. Lisa, is that okay? Okay, let's get started. All right. Good morning and good afternoon, everybody. Welcome to this joint webinar organized by 5 projects co-funded by the European Commission on the one hand and the Government of India to tackle the issue of water pollution in India. This webinar is a partner event of the EU Green Week and is coordinated by the LOTUS project with the support of the Horizon Results Booster. So please note that this webinar will be recorded. Please turn off your microphones and cameras. If you have any question, you can ask them in the chat section and we will answer them at the end. The recording of all presentations will be available at the end on each of the project's website. And now I'm leaving the floor to Anshuman from Pavitra-Ganga project, who will offer a keynote speech on the challenge of zero water pollution in India, setting the stage for our webinar. Anshuman, the floor is yours.
Thank you, and thank you for the opportunity to be part of this webinar and discussion. I've been given a very interesting topic about whether India can achieve zero water pollution, and I'll try to reflect some facts about it and whether really it is possible or not. I essentially feel that zero is nothing like absolute zero, but I think we can definitely reach near zero pollution and learn from what could be the best practices across the world. So if I may start, if you look into the, what was given to us in terms of water resources, this is what we were having with us, serene, pristine water resources. But unfortunately, what we have done to it is, we have rendered it polluted. There's a dichotomy of how we actually deal with the water resources. At one hand, we worship them in India for sure, but unfortunately, our activities also render this kind of situation where we pollute the water bodies day in, day out. And if I'm to therefore reflect upon what are the kind of current status about water pollution, if we talk about what we need to address, I would like to reflect upon that. And if you look into that, let's start with what is the state of water resource availability to us. I mean, South Asian region where we are placed in India has almost 1/4 of the world's population, but just around 4.5% of the world's water resources. It's very, very scarce resource. We are already stressed and we are moving towards water scarcity situation. Now, to this scarce situation, we already have complicated the scenario by having water pollution, which is to an extent, making the water management really difficult for all of us. So if you look into the latest World Water Development Report and the depictions on the water pollution over there, you will see. I'm waiting for the slide to come in. We'll see that a fair bit of water resources across the river stretches of the country actually lie in severe to low state of pollution. And if one were to assess that in terms of the level of reflection in terms of BOD, we fall anywhere between let's say 4 to 10 to 30 BOD milligrams per liter. And this is something that we are continuously facing since years. Despite many programs and policies that have been in place to basically reflect on the reflect on the challenges that are being addressed through those policies. I'll just see there's some issue with the slide changing. Let me just. All right. I'll switch to the slide which actually depicts, therefore, the state of water pollution. If you look into the global risk of water pollution, this is a World Bank report. It tells us that our country, in terms of BOD, nitrogen, and electrical conductivity, we are very high to we are at a very high pollution risk, and this actually affects the health and economy. In fact, a very interesting figure that was given by the World Bank report was that if we are having a BOD level that exceeds around 8 milligrams per liter, we already have, and this basically means that the GDP growth falls, by around 0.82 percentage points in downstream regions. And if we compare this with the mean growth rate of around 2.3, around a third of the growth is lost. And if we talk about the middle income countries, what we see is in the similar fashion, actually the growth is lost by almost half. So this impacts the economy, this impacts the health. And if you look into the state of wastewater, let's say generation and discharge in our country. What we know is the figure some time back that what we generate, actually it will be a bit more than what 61,000 MLD per day, but what we actually are able to treat is just around 35-37% of it. So the rest actually goes untreated into the water bodies and rivers and leaches into the ground, and basically continues to exhibit pollution. And if you want to take a look at the trends that we have seen from the past in terms of, let's say, BOD, biological oxygen demand, and bacteriological contamination, coliform, etc., we continue to see the trend of water being polluted across various stretches of the river and as well as lakes and wetlands across the country. And if you see these figures, these are basically exceedances beyond 6 milligram per liter or even more in some cases. I'll show to you as far as BOD is concerned, and likewise for bacteriological contamination in the terms of coliform. These are the latest figures up till around 2018, which also tells us the situation hasn't changed much. We still continue to have a significant number of stretches of river actually in the state of pollution, continual from the past. Now, I am to give you an example of one of the most talked about rivers in our country, River Ganga. The River Ganga basically generates almost around significant volume of sewage, of which around roughly around 50%, 46-47%, around 1369 MLD, basically is basically discharged into the river from untreated or partially treated sewage, which is from domestic sources as well as industrial effluents. And this is not too long back. No wonder why we continue to see many pollution challenges in terms of BOD, for example. As you can see, a significant level of BOD we can see in higher concentration than what is required, around 3 milligrams per liter. But besides the BOD, other pollutants have been also of the concern. For example, heavy metals and pesticides. Our own study has actually in the past shown at various stretches of the river along Kanpur, along Bhagirathi, along Kanpur, Allahabad, Varanasi, and downstream even in Hooghly in West Bengal. These are all stretches of pollution and exhibit significantly higher level of pollution over a period of time. In fact, as on 2019 as well, we continue to see a very high level of pollution to the level of around 6 milligram per liter in Hooghly as well. Now, there have been various programs that have actually considerably improved the, let's say, decreased the level of pollution. However, we have not been able to still achieve the level where we wanted us to be. For example, the NNCG had actually the target of creating around 2,311 MLD of treatment capacity, but what we have achieved till 2018 was around just 11%. Same is the case with River Yamuna, one of the most polluted river and talked about river of our country. If you look into this Delhi stretch, again, the latest figure still tells us that we have a BOD level of around 20 to 45 in the last 5 years, which continues to tell us that we still face the challenge of pollution from various domestic and industrial sources of effluents and discharges. And despite the fact that we have had programs like Ganga Action Plan and Yamuna Action Plan in the past, we have not been able to achieve the expected clean state of the rivers. The need actually is to focus beyond just infrastructural investment and rather having an integrated approach of having institutional, financial, and social mechanisms in place to facilitate prevention and reduction of river pollution. Same is the case with groundwater. We see some geogenic, sources of contamination of groundwater. Many part of our country faces fluoride, arsenic, nitrate, iron, salinity, ingress. And as you can see, several states, across the country are affected by arsenic. And again, several districts of around various states are again affected by fluoride. But besides this, we also are seeing heavy metals and pesticides continuing to be challenged to basically exhibiting state of contamination as far as groundwater is concerned. But what I want to also draw your attention is not just these traditionally known pollutants across the country, but also some of those emerging pollutants and those which we have less talked about or have not been really monitoring to the level where we should have been. Talk about plastics, for example, and this is a very interesting map which is which has been brought out by World Bank. You see, our country, we generate around 2,000 to 20,000 tons of plastics per year. Actually, this amount is basically discharged from the rivers to the ocean, and we continue to have mismanaged plastic waste generation of a significant volume, which actually is something that we need to look into as well along with. But what about other pollutants that we really have been not talking about much as far as pollution control is concerned? And if we are to achieve zero pollution, we need to address them as well. For example, the emerging pollutants and contaminants, which are basically synthetic or naturally occurring chemicals that are not commonly monitored, but have the potential to basically have adverse ecological and human effects. They come from various sources, point sources of industry and households, and non-point sources, and they find way into our river systems. And the challenge is that, they are not part of our routine monitoring, and their fate and behavior and toxicological effects are less understood. There are various, classes of them: pharmaceutical origin, personal care, cosmetic, preservatives, etc. In fact, the EU has around EU has identified as priority hazardous substance in the form of diclofenac and estradiol, E2 and E2. And more than 200 pharmaceuticals are basically known to be, present in the river water globally. And, for example, ciprofloxacin has a presence of around 6.5 milligram per liter in terms of max concentration. The problem is we do not have enough, these pollutants are not really necessarily, they can be treated by conventional secondary treatment. And we have inadequate treatment capacities as of now, or even plan of it to basically remove them from our system. So if you look into India, and if we compare from 1995 level to the 2015 level, the risk of antibiotics ciprofloxacin is significantly increased. You can see this is green and this is almost red in terms of risk level. But not just the ciprofloxacin, there are various other contaminants in pharmaceuticals and personal care products, and many of these would be known to you. Methylparathene, triclosan, etc. They are continuing to be there and finding their way from our sewages to the water bodies. But besides this, we have also radioactive substances like uranium reported in groundwater in various states: Rajasthan, Gujarat, Punjab. Nuclear waste are also have something that we need to monitor and know about them in terms of their impact. So all of these are very important components that we need to look into. So if we want to really assess our our capability to move towards zero pollution, I think we have to take a look at all of these. There have been government responses. There have been Water Pollution Act in '74. We have seen Ganga Action Plan, Yamuna Action Plan, EPA, water policy, groundwater regulation, even National Water Mission, etc. But in the recent past, these two programs of Namami Gange, basically focusing on unpolluted stream and uninterrupted stream, basically have been some of the major programs looking into the pollution abatement of not only River Ganga but also other rivers of the country, with a significant investment, committed to that, including Swachh Bharat Mission, which besides the sanitation and water component has, a sanitation component in the form of, toilet provision across and as well as solid waste management. So these
Sorry,
are really,
Anshuman,
Yeah.
can you hear me? We can't see your slides. You're stuck on slide 12. Has that come through?
Which slide can you see now?
We're seeing slide 12 at the moment. So
Okay, let me escape and then come back. Can you please see slide number 18 now?
No.
Yeah, maybe try unsharing and then resharing.
Okay. Unfortunately, there's a lag in this. Okay, so there's this very slow response I am seeing now.
Or we can show them from here if you prefer.
Yeah, please go ahead if you can.
Okay. Okay, 1 second. Okay.
Can you see the slides, by the way, now?
Yeah, it's a PDF we can see.
Slide 18.
Slide 18 is now, yeah.
Yeah,
No, just make it full screen.
Yeah. Can you see the full screen now? No.
Yeah.
Yeah, it's
Like,
fine.
okay. I was talking. Did you see these slides? No.
No.
Yes. Now, yes. No.
Okay.
We can.
Okay. Maybe I'll very quickly run through them because I talked about. I talked about this plastic pollution. Besides the groundwater and other aspects, I was talking about the emerging pollutants to be focused as well. So this is something that shows the level of magnitude of pollution for plastics. I talked about the emerging pollutants and their behaviors. I mentioned about their point sources and non-point sources, as well as different categories of pollutants that are across, which are of importance to be looked into. I also mentioned about the fact that we need to have a look into all the range of pollutants and especially the emerging pollutants like pharmaceutical products, etc. Besides the radioactive substances, which also have been reported in the past from various parts of the state. I was talking about the government responses, wherein several of the policies and regulations have been in place. However, we have not been still able to achieve the clean state of the river. The recent one were the Namami Gange and Swachh Bharat program, which Namami Gange focuses on unpolluted stream and uninterrupted streams with significant investment, and like with Swachh Bharat mission with the component of sanitation, focusing on toilets. The point that I wanted to emphasize now was, therefore, what needs to be done if we are wanting to achieve zero pollution. And I think that the answer lies in the fact that we need to have a very integrated approach as far as managing zero pollution or achieving zero pollution is concerned. And if you look into what we need to focus first on is basically the sources of pollution itself. If you look into the various natures and kinds of sources, you'll find there are a wide variety of sources from which we actually imbibe pollution. Households, indoor and outdoor industries, different construction, industry and commerce, agriculture, livestock, crop production, transport, road and railways, for example, sites and landfills, etc., etc. From all of these sources, we actually see either untreated or partially treated things, the pollutants finding its way into the water streams or water courses, and part of it basically leaching or infiltrating into the ground and ultimately posing a challenge for us in terms of contamination and pollution of water bodies, both surface and groundwater. Now, all of these needs to be brought into the agenda of achieving a zero pollution. We need to find those sources which are not only those sources which are known to us, but also those which are possibly not so well monitored. As I mentioned about some of those, in terms of emerging pollutants, a combination of which we need to look into in terms of addressing the pollution. Now, that's about the sources as far as pollution is concerned. We need to have an integrated approach where we need to have a reduction in wastage, resources recovery, improving efficiency and productivity, and conservation and zero discharge all together in every sector, be it agriculture, domestic, or industrial sector. We need to focus on an integrated approach. All of these components are linked with each other. Now, if we have to, really focus on, a zero pollution state, what we need to address is the imbalances that exist as of now. Now, of course, one of the most important component is the pollution prevention and control. We need to have full collection of the sewage, its treatment, even maintenance of the infrastructure of the STPs, etc. Focus and move towards recycle, reuse, and resources recovery, and also look into the standards and norms which needs to be revised in the current context rather than the historic, norms that we have been following in a period of time. Now, all of these are interlinked, and therefore we need to have a focused approach of bringing the other components along within the agenda of water pollution control, which includes, for example, water use efficiency in all the sectors. We need to have existing capacities of the agencies to be improved, need and training, and capacity building of all the existing agencies with up-to-date knowledge. An integrated approach would also mean that we have a circular economy in place. So we need to, I'll talk about it in a while. Inclusive solution of involving the stakeholders, institutional coordination where we need to do away with the multiplicity and integrated decision making, and more importantly, as far as India is concerned, an effective implementation framework, something that we have been missing. We have good policies, but the effective implementation has been missing. Of course, the financial reforms in terms of incentive and disincentive mechanisms should be forward-looking, and we need to have adequate, water pricing. One thing that we talk less about is about the data. So we need to have, more and more data on the latest pollutants as well as their status and widespread, knowledge across the three-dimensional space in terms of real monitoring and use that data for effective decision making on a real term. We also need to have circular economy approach as far as water is concerned. We need to move away from that end of the pipe treatment solution to a restoration and regenerative, approach by intention and design. We need to do away with the, toxic chemicals in our usage, and as well as we need to have superior design material in our business models. And therefore, we need to look at water as a product which has, energy, nutrients. We can reuse it, prevent its pollution, and have a value chain approach. And also as a resource where we need to have demand management, more efficiency, zero discharge, neutrality, even water positive approach as a approach towards the entire circular economy. So I think these are very important components as far as our aim of moving towards zero discharge or zero pollution approach is concerned. There are some examples from within our country. For example, we have audited a number of industries, and all of them have shown that there is significant opportunity. I'll just take one example amongst that. For example, the largest thermal power plant of the country had a recycling possibility of wastewater and saving around 17.9 million meter cube of water with a financial saving of 72 million rupees. And likewise, we have in our project also identified two examples of Tamil Nadu, where the STP basically reuses a significant volume of water and is sent to industry, and also generates biogas, which actually makes its STP almost 98% self-sufficient. And likewise, the case of Rithala in Delhi, where basically again the water is reused for gardening and thermal power plants, and also there is a production of energy which makes around 35% of the STP's electricity demand met. Besides, in both the cases, also monetary saving. Now, the point that I wanted to emphasize, therefore, was that all of these approach needs to be looked into in a manner where we need to bring in the recent approaches, best practices, and look into a policy which basically focuses on an integrated approach and move away from that typical end of the pipe solution and focus more on the current challenges, the current range of pollutants, if we are to move towards zero pollution. I'll stop here. Thank you for your time and opportunity. I'm sorry for the technical glitch that happened in between, but I'll be happy to take any questions later on. Thank you. Over to you, Lisa. Lisa?
Yes, I think it's Kevin's turn to present.
Okay, sure. Thanks.
Okay then. Thank you very much. And Schumann, if you can stop sharing.
Yeah. Right now, yeah. I've done that. Guess there's a lag again.
Let me know if you can see that.
Yes.
Lovely. So, ladies and gentlemen, my name is Professor Kevin McGuigan. I am the European coordinator of the PANIWATER project. The PANIWATER project consists of 18 partners. We have 12 in Europe, in Ireland, the United Kingdom, Spain, Italy, and Cyprus, and we have 6 partners in India. The purpose of PANIWATER is to develop 6 technologies for the removal of contaminants of emerging concern, so-called CECs, from drinking water and wastewater. The drinking water technologies are intended for use to make greater availability in remote areas, and the wastewater treatments will allow reuse using advanced oxidative processes as additional treatments added on to existing wastewater plants with the intention of making the effluent CEC free and fit for irrigation purposes for food crops. We have demonstration sites identified in Delhi, Udaipur, Bundelkhand, Nagpur and Khagalia. And in addition to the technology developments, we have a work package specifically concerning the social science implications, because the technologies are useless without appropriate buy-in from the key stakeholders. So our intention here is to enhance understanding of the technologies around the area and also understand the existing situation in our areas of interest, to engage with key stakeholders in these areas to understand the training, capacity building and behavior changes that are necessary for the implementation of these technologies. The technologies are in some cases being developed in cooperation, so-called co-designed model, in cooperation with these key stakeholders. And ultimately, the purpose is to develop technologies and practices that assist in promoting good water governance systems. Those with the least access to tap water are among the most socially underprivileged, the lower income households. And this is despite recent initiatives such as the Jal Jeevan mission to improve access to safe drinking water in rural areas before 2024. Even despite this, we still have concerns surrounding the need for technology interventions. We still find women having to walk many miles to collect safe drinking water. And because of the water scarcity situation, we find farmers are using the existent effluent from wastewater treatment for irrigation purposes, even though that effluent contains contaminants of emerging concern. Our social science colleagues have conducted a baseline survey, which is quite an accomplishment given the pandemic that we're all living through at the moment. They had to revert to census data, but we have a good idea of the existing drinking water, sanitation and hygiene practices in the households in the two areas that we're particularly interested in, which is Delhi and Madhya Pradesh. Our baseline survey has indicated that 44% of the households in our areas of interest have access to tap water, 41% rely on hand pumps or tube wells, and when they get the water home, 35% are either boiling, filtering, or doing some form of water treatment before it's consumed. The situation regarding wastewater is much more concerning. While 72% of the households might be connected to some form of drainage system, only 12% are connected to a form of treatment, and reuse is almost non-existent in these households. And it's reuse that we're particularly focusing on in the wastewater area, because it's a resource that at the moment is not being utilized. We feel Madhya Pradesh and Delhi are good areas to focus on, because as you can see, they're right in the middle of the National Survey of Progress towards SDG 6, the Sustainable Development Goal 6, for access to safe drinking water and sanitation. So as of 2019, they were less than halfway towards achieving this goal. So we feel it's an appropriate area to focus on. The contaminants of emerging concern, well, there are contaminants of existing concern. I apologize for how small the details are here, but what I'm trying to show you is we have done studies. Our colleagues in NERI, Madam Rita Dodabkar, the Indian coordinator of PANIWATER, her group has detected all of these contaminants of emerging concern in the wastewater in the areas of study. So they are existing. It's not just some kind of notional risk. Consequently, we're developing 6 technologies. The first 3 are to do with wastewater treatment. Now, for reasons of intellectual property, we can't show you diagrams of the actual technologies, but we can certainly show you how they're being used. So our first technology is our MFR, the multifunctional reactor. This is a combined physico-chemical treatment and advanced oxidative process using ozonation. The photographs show you an existing sewage treatment plant at an Air Force base quite close to Niri in Nagpur, and they have very kindly agreed to host our pilot MFR plant as an add-on to their existing treatment. And this is fabulous now because we're getting this combined treatment in a single step in a decentralized sewage water treatment plant. And this is the purpose of our wastewater treatments. We're particularly intent on developing decentralized systems because they're more appropriate for smaller communities. We think this is the way forward with regard to sewage treatment. The second technology is a solar photocatalysis technology, the SPP. Here we have looked at combined hydrogen peroxide and persulfate driven either by UVC or solar energy, and also looked at solar photophenton combined with activated carbon as a method of inactivating biological pathogens in the wastewater. And we've settled on a combined UVC hydrogen peroxide in a system driven by a photovoltaic electrical supply. And you can see from the graph on the left-hand side, we get a very dramatic reduction in the pathogen populations in a very short period of time. And the nice thing about what we see here is that we see no subsequent regrowth. So it is a complete inactivation of these microbial species. We have a pilot plant ready on the campus in Niri to receive the SPP prototype, which has been developed by our colleagues in Cyprus. The last wastewater treatment technology we're looking at bench scale. There won't be a pilot plant in India for this. This has been developed by our colleagues in the University of Ulster. And it's photoelectrical catalysis, the PEC system. This is photocatalysis, but what we're doing here is we're applying an electrical voltage across the reactor space, and that facilitates a longer lifetime for the oxidative species that are generated in the photocatalysis. And this facilitates a much more effective inactivation of the biological and chemical contaminants. As you can see from the graphs showing virus MS2 removal and sulfomethoxazole degradation, and this is using a special photoanode that they've developed in University of Ulster based on tungsten oxide. And this is our unique selling point for this technology. The nanostructures are much more effective than the existing titanium dioxide, the P25, that you see in the graphs. Moving towards drinking water technologies, the first technology that is being developed is our FAU prototype. That's filtration, adsorption, and UV. This is being led by Professor Prakash in BITS Pilani in Goa. And what we're doing here is the water is being passed through activated charcoal before it enters a reaction chamber within which we have an array of UVC light-emitting diodes. These are very, very effective for inactivating bacteria. We have secured the LEDs from our SME partner, Quality PP in Hyderabad. We have completed initial studies demonstrating that the inactivation is as required, and we've completed studies for optimal distribution of the LEDs within the reaction chamber. So we're now in the process of building the prototype and taking that to pilot studies. The next drinking water technology is our electrocoagulation and oxidation device developed by our partners in Auroville in India. What we're doing here is they have developed new electrodes around which the contaminants of fluoride, iron, and arsenic are made to precipitate out. So we're effectively removing iron, arsenic, and fluoride from the water prior to consumption. We're getting very good results. It's a very promising technology, and it's all driven by photovoltaics. The final technology looks like the simplest. This is a transparent jerry can that will be used for solar water disinfection. At the moment, there are about 2 million people using solar water disinfection around the world. They tend to use 2-liter PET Coca-Cola bottles. We have developed a 10-liter polypropylene jerry can so that it provides an amount of treated water suitable for family use. We find polypropylene is a much better transmitter of UVB and UVA, so we're getting much better inactivation results compared to the 2-liter PET. The intention would be ultimately we would hope that these jerry cans would replace any jerry cans that people currently rely on. So it would extend the life of these jerry cans to make them a secondary use container. I'm going to leave it there, ladies and gentlemen. That's the end of my presentation. Happy to take any questions at the appropriate time. And I'll hand you back now to the organisers.
All right. So now let's get started with the LOTUS presentation. 1 second, please. Can you see my screen?
Yes.
Yes.
Right, then I put on slideshow mode. Right, so this presentation is about to present the LOTUS project and how its technology is supporting the improvement of water quality in India. So what is the LOTUS project? The LOTUS project is a project that is co-funded by the European Commission and the Indian government. It gathers 22 partners from 6 countries, all over 5 states in India and Europe. It is a 4-year project and we're about halfway in. So our approach in LOTUS is very much to co-create a technological and a multidisciplinary solution with Indian partners. So basically, for the first 2 years, we are developing a new technology that I will present afterwards. Then this technology already exists in lab, and the idea is to take it to the field. So very soon we will take our technology to the field and start discussing with the people on site to make sure it works properly, and then refine our product to have the best solution in the end. So what is our technology? Our technology is its sensors that monitors water quality real time. So the idea is that you take a sensor, it's about this size, you put it in the water, and then either with wire or wireless, it sends the data. The data is then analyzed with many softwares that we're developing, and we can monitor the water. So that's our technology. So what's beneath it? The sensor that you can see here has a head that has a chip onto it. And this 1 centimeter chip is covered with graphene that enables to monitor several things at the same time. So here we can see we've already achieved to monitor temperature, conductivity, pH, and chlorine. How does it work exactly? It is a nanotube technology. So you can see here, we define a chemical property, and then it comes and it fixes on a nanotube, and that enables us to monitor anything, any molecule that can be characterized chemically. So as explained, in 2019, when we started the project, the sensor worked in lab. Our objective is to have a demonstrator by the end of the LOTUS project, so in 2023, 2024. With that, I mean, the sensor doesn't work alone. It is connected to ICT technologies that enable to monitor the data. What's interesting in the LOTUS project is its versatility. We plan to implement our sensors in very varied cases located in different sites of India to show that our that data monitoring supports the reduction of pollutions in very different cases. So the first cases is the Guwahati water distribution system. So Guwahati is a city north of India that is undergoing important demographic growth. The pipe water is irregularly supplied through pipes, and this has a direct impact on water quality. Basically, the pipes are not always full, and this carries on a lot of contaminants. In parallel to the LOTUS project, the Guwahati system is developing a water distribution system that will work 24/7. Because the pipes will be full with water all the time, it's an opportunity for us to really monitor the quality and ensure that the water that comes out of the pipe is clean. To do this, we created a digital twin of the network, and we place strategically the sensors. And the sensors, they can tell us in real time if there are water contamination, and depending on the results, we can shut and open the networks to make sure that there are zero contamination in the network. The second case is about groundwater management seen in Guwahati. Basically, if some people benefit from tap water in Guwahati, most people rely on groundwater, and they pump water from the wells. And in Guwahati, you have a geological specificity where you have a lot of arsenic and fluoride that are naturally present in the soil. What happens is that when people are overpumping the table, or if it rains, the water goes up and down in the table and it scratches the contaminants, and then you have contaminants going in the water table. The contaminants, they are moving, right, in the water table, which means that wells are not contaminated all at the same time, but sometimes you have higher levels of contaminations. So what we do here is that on the one hand, we are modeling the way contaminants are moving in the table, and on the other hand, we are placing sensors. We take a string and we drop the sensor in the well, and we take the level of contaminants, and combining this real-time information with our model, we can know exactly what well is contaminated, what well isn't. And the idea is to combine it with a community information system, like a red light, green light system positioned strategically next to the well to let the population know whether the water is safe to drink or not. We're using LOTUS in a complete different case. This case is irrigation. So India really needs agriculture to feed its population. And the issue is that there is overuse of groundwater for agriculture. We have a second challenge, is that because we use a lot of fertilizer, the groundwater that is used for irrigation is also highly polluted. So the idea is to move from a traditional groundwater irrigation system to a drip irrigation system. And in the drip irrigation system, we want to have the fertilizers that give exactly the right amount of fertilizer to the plants. And that's a solution we're developing with an Indian company that is called Jain Irrigation. And the LOTUS sensor will be placed in the fertigation system to make sure that we give exactly the right amount of water, right amount of fertilizer to have the best plant growth and the most limited pollution for groundwater. This is currently under development. So as said before, LOTUS is very versatile. So we developed another system for a complete different cases. In Bengaluru, a city south of India, there are a lot of water shortages. And basically, people, they cannot pump water anymore in the groundwater because there are water shortages every year. So what happens is that so that the population has enough water in summer, you have trucks, they pump the water out of the city and they bring it into the city. What happens now is that these trucks are completely unregulated, and they supply water to people and we don't know what is the quality of this water, which is a major issue because the people are really using this water for their even drinking purpose, and they really need this water. So what we wanted in LOTUS was to guarantee that in the tank the water you get is clean and is proper for consumption, and you won't get poisoned with it. So to do it, what we did is that we positioned 2 LOTUS sensors, one next to a RO plant location, a reverse osmosis plant location. So we take water, we treat it, we put it into the tanker. Then we have another sensor that is placed directly into the tanker and then monitors the water quality during transportation. If there is a contamination in the tanker, we placed a chlorination station on the truck, and we make sure we guarantee basically with our sensor that the water is clean from the source all the way to distribution. So this solution is co-developed with an Indian company that is called Jaspani that manages trucks in Bengaluru, as well as a company in Germany that's called Autarkon that has developed the chlorination system. The last case where we use LOTUS is for wastewater. So as Kevin showed, like wastewater is not always really treated, and what we still have a lot of contamination that is not managed at the wastewater treatment and then that is sent to the environment. So what we wanted with the center was to improve the way the wastewater treatment plant and really monitor like sensitive contaminants such as nitrate and ammonia. So this is currently under development in a wastewater treatment plant based in a research institute. So showing these 5 different case studies, what we want to show is the versatility. What LOTUS does is monitoring. At no point we're doing water treatment. The water treatment solutions are brought by other partners as part of the project, but our data and the versatility of our sensors that is able to monitor any particle as long as it is chemically characterized enables a lot of use that are tackling water solution all along the water cycle. So now let's get back to our primary question: how to reach zero water pollution in India. LOTUS is not a one-fit-size-all solution. It is a monitoring solution using and collecting data. But we have isolated 3 factors of success to reach zero pollution in India. The first one is co-creation. Like all our solutions are completely designed with Indian partners, and we've done co-creation people with the end users to make sure a solution perfectly matches their needs. The second thing is the versatility. So our sensors can be basically used in any application cases. So it depends then on the creativity of local people to use it and develop new solutions. And we will be here with them and with our partners in India to support the co-development of the sensors that really works for everybody. The last thing that is very important is that the sensor we're developing will be manufactured in India. And that's very important to us. And basically, by producing a lot of sensors, we enable economies of scales, and we make our sensor very much upscalable. So from a solution that it will be currently used in 5 demonstrators in India, we would like to have a solution that can serve the whole Indian country to sort the challenge of water pollution. Thank you for your attention. And now the floor is to Paul on the Pavitra-Ganga project. Ruben.
It's Ruben, yeah.
Yeah, good morning, everyone. I think you can see my screen now. So, yeah, good morning to everyone. My name is Ruben Rodriguez. I'm from Leitat, and I want to introduce you our project India H2O, a biomimetic and phytotechnologies designed for low-cost water purification and recycling. First of all, I want to make an overview of the project itself, which is located in India. where water treatment is not easy till now. So India H2O projects want to develop, design and demonstrate high recovery and low cost water treatment system for saline groundwater and industrial wastewater. Why this kind of water? Well, in the next slide, I will try to explain that and make that make sense. The focus for development will be in the arid state of Gujarat, where surface water resources are very scarce. The reason of this selection will be explained later. And cost-effective technologies and systems are proposed to lowering energy cost, improving the energy efficiency. Has a new bio-based approach to water recycling and use of renewable energy, and the rejection of waste streams will be minimized or reduced to zero, thus protecting the environment. The project includes all these activities, but has different specific objectives, which are the development of a novel batch reverse osmosis technology for a reduction of the specific energy consumption, the development of forward osmosis with biomimetic membranes technologies for use in wastewater recovery applications and an overall reduction in specific energy consumption, the development of Phytotechnologies solutions for rural domestic wastewater treatment, create a center of excellence in water treatment membranes technologies in India for design operation, piloting, demonstration, training, and dissemination of these technologies in this country. Development and demonstration of a cost-effective and high-efficiency forward osmosis and batch reverse osmosis system for industrial desalination. Develop and support the evolution of business model to exploit the developed solution in the project in India, and brief and influence policymakers on economic models and governance arrangements for viable adoptions of these technologies in India. All these systems will be developed and integrated as pilot-scale prototypes that will be integrated with renewable energy sources under real operational condition in the village of LOTUS in Gujarat. But the question is, why Gujarat? Well, this is an arid region having low rainfall compared to most of the rest of the country, and this makes more necessary the inclusion of low-cost treatment to supply the population with fresh water. Here, there are few surface water resources because it just have 3 perennial rivers. Gujarat is the third most wealthy among 29 states in India and has a great rural population of about 57%. But the decisive reason of decide to locate the project here is the salinity of groundwater. As you can see on the map in the lower part, the salinity is one of the biggest in India, and the fact that it's a very industrialized state and many of these industries are water intensive. So, due to the prior points, our project is focused on treatment of saline groundwater and industrial wastewater. Gujarat has a range of industry facing challenges of increasing water cost. They have difficulties of obtaining enough water and the disposing of the effluents. That's why a higher level of water reuse is attractive to them to save cost and help meet environmental regulations. The two types of industry represented in our project are the dairy industry in one hand, which is a very large industry in Gujarat. This industry have a cleaning system, which is called a cleaning place, or CAP, and involve washing the equipment alternatively with acid and alkali solutions. It produced a large volume of washing, as you can imagine, and with our system proposal, we want to recover those reagents and produce clean water at the same time. The second industry, textile and dyes, on the other hand, is also very significant in Gujarat. The process is energy intensive and without much water recovery. So the objective is to recover dyes using membrane technologies and produce clean water. About the legislation in India, And the groundwater legislation continued to fail to address environmental principles, such as sustainable use and precautionary principle. The specific policies related to reuse of water are practically non-existent, except the general water quality standards that are defined at national level for various purposes of water use. Reuse of water now takes place informally and often unconsciously when people utilize wastewater flow without awareness on origin of the flow. This means that people are exposed to risk related to the quality of the water, especially in the absence of low-cost technology to treat the wastewater before use. Prerequisites for introducing these technologies and encouraging reuse of water are sound policy and regulatory intervention by the Indian government. Only in this way, water reuse can be utilized in a safe, effective, and sustainable manner. In the process of developing policy frameworks for recycling water, we have to pay attention to which part of the society are relying on recycling wastewater to avoid the risk that reused water can produce in those parts of the society. So the question is, what are we doing in India H2O projects to help address such issues? In this framework, advanced membrane processes are being developed and combined to provide new methods of purifying water from saline groundwater and from municipal and industrial wastewater, providing one that is safe for drinking or suitable for irrigation. To help us to reach and maintain this objective, low-cost sensors for real-time monitoring of the key parameters will be integrated with monitoring and management systems to ensure sustainability of these systems. India H2O project will assess both physical and social aspects of groundwater management and governance. We have reviewed the legal framework that are in place and assessing the real scenario to see how groundwater usage is really governed in practice. The technologies that makes these projects possible are the next and are based in different and numerous principles. The first one is the batch reverse osmosis for groundwater desalination, which is an innovative approach that increases the efficiency of reverse osmosis and lowers cost, presenting an ideal solution for widespread deployment in arid regions like Gujarat and industrial processes where high recovery of water is essential. The main advantage of these technologies are it has a high recovery ratio, minimizing brine, has a near thermodynamic ideal efficiency, has the option of being used with solar power production, and is used with low pressure membranes. Other membrane technology is based in biomimetic membrane in some processes such as forward osmosis. This technology is a new bio-inspired technology which can be used in combination with other membrane processes like RO, reverse osmosis, or nanofiltration through the basic principles of osmosis, which is familiar in everyday life. Some characteristics of forward osmosis are the fact that this membrane process is driven by salinity gradient, which can be naturally occurring or induced, and is less prone to fouling than pressure-driven processes. These membranes allow water to pass through the channels, blocking all other impurities regardless of molecular weight. This membrane can also be used for forward osmosis and reverse osmosis. And the draw solution and its osmotic pressure is a crucial aspect in this kind of technologies because it's the driving force of this technology. So it is important the decision of which solute use as a draw solution. And in this aspect, we have a lot of possibilities. In this project, we want to introduce as well some phytotechnologies in order to reduce pollution by using plants, helping us to embrace a more ecological approach. Glycophytes are one of those phytotechnologies that can be used in various ways to treat domestic water, usually by percolating the wastewater through the roots of these plants. For an agricultural country like India, this can provide a lot of added values at the process, can be provide dual benefits, phytoremediation and fertigation. Halophytes tolerate and absorb salts and are edible at the same time. This plant can help us to manage with the brine obtained after the application of a batch reverse osmosis from groundwater, allowing us to reach that zero waste concept. These vegetables can then be used as a food source for the population, as a reference for all of us. This type of vegetable has been cultivated for this same purpose in Israel for a long time. And in industrial uses, the technologies that we want to suggest to use are for dairy industry. The use of membrane technologies can be helpful to reduce the pollutants present on the streams and allow us to remove components that can interfere on the rest of steps. Reagents for cleaning plate process can be recovered using electrochemical technologies and obtain acid and alkali solutions to be reused once more. For textile industry, the use of membrane technologies can recover dyes to be reused, which is important for lower cost of reagents, and the water can be purified, applying novel technologies known as advanced oxidation processes, which can remove contaminant of emerging concern. As you can see, our prosperous collaboration of skilled Indian and European partners are helping to deliver India H2O ambition of high recovery, low-cost water treatment system for saline groundwater and industrial wastewater, which has been made possible with funding from European Commission and the Indian Department of Biotechnology. If you want to know more about the project, you can visit our website, where you can find more information and even watch some videos or publication we made within the project. Thank you.
Paul, you're muted. Yeah.
Mute. Hello, can you hear me?
Yes, we can.
Yeah, can you see my screen?
Yes, we see your screen.
Right, it's just going on presentation mode. Hang on a second. Let's see if it's... Okay, can you see it?
We do, yeah.
Yeah, okay. Thanks very much, and good morning and good afternoon to everyone. My name is Paul Campling from Vito in Belgium, and I want to present to you the approach that Pavitra-Ganga is doing towards delivering zero pollution in India through wastewater treatment and resources recovery. So first of all, I just want to give you an overview of who we are in our consortium. So we have in total 14 partners across European Union and India. We have 9 research and innovation partners from the universities and RTOs. We have 3 SMEs. We have a water utility company, and we also have an industrial partner. So the objective of Pavitra-Ganga is to unlock the environmental and economic potential of wastewater treatment, reuse and resource recovery. So we're basically promoting the circular economy approach to deliver or help to deliver the sustainable development goals of clean water and sanitation for all. Within the project, we're basically working around 3 different domains. We have water governance, which is there to make sure that we are engaging with the stakeholders and providing policy support where relevant. We are also developing technologies around wastewater treatment and resource recovery in the laboratories, and then going to develop them and pilot these technologies in the field. At the same time, we're also developing water monitoring and modeling techniques to ensure that we have better information about pollution within the 2 case areas that we're working in. So, and in addition to that, of course, we have our capacity building activities to make sure that there is good transfer of knowledge and technology between the partners, and to ensure that there is a continuation of the project afterwards. Right. Okay. Now, and just to give you a bit of information of where we're really working. So, of course, we've selected 2 case areas that we're focusing our attention on. They're 2 quite different cases. The first one is in New Delhi, and it's the Barapula drain, which is a very large stormwater drain which is flowing through the heart of New Delhi. And over the years, with a lot of developments but inadequate infrastructure, there is a lot of polluted domestic and industrial waste coming into this open drain. So it's basically moved from a stormwater drain to remove excess rainfall to actually an open sewer. And we're, as Anshuman demonstrated, showed in the first presentation, there are a lot of emerging pollutants coming out into this drain water. So we have heavy metals, pharmaceutical residues, and antibiotic resistant organisms, and of course a lot of solid waste coming down the open drain. So that's our case study case area in New Delhi. And then the other case area is at the Jajmal treatment plant, which is on the outskirts of Kanpur city. And this is very a special situation because there's a large cluster of tanneries, and the resulting fact is that a lot of the industrial waste is actually mixing with the domestic sewage. So we're actually having a large amount of problems with the emissions coming out of the tanneries. So we have evidence and detected high levels of chromium in the water, and also sulfates and nitrates. And in addition to this, there is also a long-standing wastewater reuse scheme, which is downstream from the Jajmal treatment plant. And this is heavily impacted by the fact that of these pollutants not being taken out of the wastewater treatment, which is delivered to the farming areas. So this is we feel these are 2 very important urban case studies to work at. Now, water governance and socioeconomic issues are an important part of the project. We know that engagement with stakeholders is essential because we really want to understand the situation. We want to work with them and co-create to look for solutions. And of course, if we want to eventually implement some of these solutions, we have to collaborate properly with the people. So last year we were lucky enough, just before the pandemic broke out, to have 2 really interesting stakeholder meetings in Delhi and in Kanpur. And one of the good outcomes last year was to really look at develop a policy brief around case studies across Europe and India to identify the barriers and factors for good water governance. And this can be downloaded from our website, this policy brief. And I just wanted to communicate a few of the key messages from the policy brief. So, of course, on the socioeconomic issues, low cost recovery is really a big issue in India. And that's leading, of course, to poor operation and maintenance of the standard treatment plants. And that, in effect, means that there is a low performance of STPs generally across the country. and only really 50% of the SDPs are currently complying to the water quality norms. And of course, to start solving the problems, we need to have improved water governance, and we need to really strengthen the institutional and monitoring capacity in India, and maybe look towards targeting our policies better. So that would help us to, we believe, through those mechanisms to improve the enforcement strategy for pollution control. And of course, because we're trying to promote circular economy as a means of delivering better wastewater treatment, national water reuse standards are definitely needed in India, so that we can make sure that the water which is provided is safe, and that if we have a national standard, there will be a level playing field across the country. So these are, I think, important issues and messages coming from our policy brief. In terms of the wastewater safety planning, we are adopting the approach developed by the World Health Organization around sanitation safety planning. So we're reworking that basic integrated approach where we identify the risks and look for mapping out some of the problems and developing programs. It's an iterative circular process. So we think this is a good approach to ensure wastewater safety. And as I say, our focus at the moment has been around Kanpur, because this is a long-term irrigation scheme which is receiving treated wastewater for irrigation. We know that there are issues of contamination of the groundwater and soil problems as well, because of long-term delivery of inadequately treated wastewater. And of course, we're on the ground. We're working with Solidaridad, who are working with the tanneries to improve best available techniques around the tannery sector, and also they're also working together with the farmers to resolve some of the problems in the rural areas. So we see this as a good collaboration. And in terms of some of the technologies, I want to quickly go through the technologies which we are testing. Of course, we are doing laboratory tests, but we're also looking at the real world situation. So we want to really pilot some of these technologies to make sure that they work in the real situation. So we have the Anticos system, which is combining concentrated sewage and organic wastes to improve anaerobic digester efficiency. So this is a way of not only delivering water for non-potable reuse, but also with the anaerobic digester being able to produce green energy and also fertilizers for farmers to use. We have the self-forming dynamic MBR, which is basically a low-cost energy pseudo MBR, which forms a biological layer and supported by an inert mesh. So this is going to be piloted in Kanpur. We've also got polishing techniques to remove micropollutants, so structured adsorbers, which we design and make sure that in this case, we're designing them to remove chromium. And we are developing further the well-known nature-based solution of wetlands by including layers of substrates, adsorptive substrates to remove heavy metals as well as deal with other pollutants. So this is also going to be piloted in the field. Other polishing techniques to remove pollutants is the solution brought to us by AquaQ, which is one of our SMEs, and they have a system where they have the AquaTrack technology to track or fingerprint pollutants which are coming through an MBR, and then removing those pollutants with ozonation. and photoactivated sludge, which is really a merger of high-rate algae ponds and activated sludge to remove nitrogen and other organics will be set in place at the Barapilla drain, along with the clean blocks, which is a low-cost technology to remove suspended solids. And of course, and as I said at the beginning, we're not just doing innovation around wastewater treatment and recovery. We're also developing approaches and technologies, demonstrating approaches to monitor pollution. So we have the mobile sensors solution which are connected to smartphones and the dashboards, which will be tested in the two areas. We also are setting up a stationary sensor system which is triggering grab samplers, so that we take samples when there is a pollution event. And as I said, we have the AquaTrack system where we're fingerprinting the effluent coming out of the MBR, and if there are any contaminants still in there, it triggers a sampler and also triggers the ozonation treatment as well. So that's on the one side, the monitoring, and then on the other side, we have the modeling approach in the two case areas. We have the WISE system, which is basically mapping out the different emissions across in the catchment areas. And then the WEEP model, which is there to develop the scenario analysis of what happens with if the technological interventions are put in place, what will be the outcome in the long run. We're also having bringing in climate scenarios as well, so it gives us a better means of planning for the policymakers, and of course, as always, a dashboard to communicate the information effectively to policymakers and eventually the general public. But I wanted to, out of what we've been working on so far, I want to come up to communicate the sort of what we see as three ways for the circular economy to deliver zero pollution. The first is that we need to make sure that we circulate materials as long as possible and at different levels with different cascades. And we're showing within the project that we can produce green energy and provide nutrients for the economy. We're also recovering some of the metals that we're taking out. So it's a question of reusing the resources which are in the waste. And of course, if circular economy is going to deliver zero pollution, we've really got to incentivize resource recovery and safeguard economic viability. Without that, it's not going to work. Wastewater reuse has to be seen as a really viable alternative water source. So that means that the water pricing should reflect the actual costs of delivering water, and it needs to be followed up with stricter control and follow-up of freshwater permits. Otherwise, there will be no incentive for farmers to develop wastewater reuse systems. And of course, that entails a new business model or sharing economy thinking to promote wastewater reuse and resource recovery. But the final message really is that there's no point in providing a solution for scarce water resources if the wastewater reuse that we provide as an alternative is unsafe. So we really got to make sure that our wastewater is completely safe, and we have to establish the risks of the wastewater through the wastewater safety planning. We need to improve our monitoring and analytical protocols to check out that these emerging pollutants are not really causing more problems than it's worth. And of course, finally, we have to deliver proven polishing technologies. Otherwise, we are causing problems which are not intended. So this is basically the message I want to bring from the Pavitra-Ganga project. If you want to go get some more information about our technologies, go to our website. We're also active on social media, and we also have a newsletter. So I hope you will be interested to receive that newsletter in the future. Thank you very much. And on to the next speaker.
Mirko, you're muted. Mirko, you're muted. You can click on your microphone.
Hello?
Yes, we can hear you now.
Yes,
We
it's
can
working
hear
now.
you.
Yes.
Yeah.
Perfect. No, it was not muted, but I think it's some slow. Can you see my screen now?
No.
No.
Wow, that works good. Try to go. I try again to share it. Can you see it now? Hello?
No.
No.
Not yet. No.
But I can share it.
Yeah, that would be good. I don't know why. Here it says it's shared. But I also had some problems this morning with the internet connection. But if you can open it, would be great.
Okay.
Now we can see it.
Yeah, all good.
Okay, perfect. Yes, then welcome to PAVITR. I think most of the points that we mentioned before. I would like to present a little bit like the project itself and also our progress. PAVITR now is running for nearly 2 years, and we are also trying, like many of the other projects, to tackle the problem of wastewater. But we would like to see it not really as a problem, but more as an opportunity, because most of the infrastructure which we have in the Western world is not yet in place, and I think this one also gives a big opportunity to establish, let's say, more adapted, decentralized solutions, which allow a much better reuse of resources. The objectives we are following in PAVITR are to develop and to validate innovative solutions. We have selected like a basket of technologies. I will come back later to this, which allows a treatment, reuse, not only of the wastewater, but also of the resources like phosphorus, nitrogen in the wastewater. We also would like to put a big focus on producing marketable materials with our systems in order to have like a commercial solution in the end. And this one leads to the last point. We will develop and demonstrate the applications, but we will also, within the project, involve companies from Europe and India in order to have a market entry of this solution. Otherwise, as you know, the projects are finishing and then everything stops. Therefore, one main focus is really to empower local people and local companies to take the approaches forward. The technology scope is we have a mix. We have nature-based treatment technologies like constructed wetlands, short rotation plantation. We also go for, like, let's say, adapted high-tech standard solutions like sequence batch reactors, which are well known, but we are testing a solution which is treating the water, but it's not treating the nutrients. That means we're getting like zero pathogens, but high nutrient output in order to use this water directly for irrigation purposes. We also have projects tackling emerging pollutants, and we have projects where we apply drinking water and also try to get rainwater as safe and as fast as possible into the ground. And of course, all our systems are equipped with sensors in order to understand better how everything works. And this sensor development is also part of the project. We have 14 pilots. I will show you later on the map where it is. And after negotiation with the DST, we come up roughly with 50,000 people treated or handled. The road to the market is quite clear. We will have training and know-how transfer workshops. We have business plan developments together with Indian companies in order to create green jobs. And we have a business plan for upscaling and multiplying. I think one important point for political stakeholders is the decision support system. That means for which situation, in which location, which system has the best application potential. I think the methodology is quite clear. We have 10 work packages, starting from the development to the design, the construction, the application. We are right now in work package 3. That means all our prototypes are more or less built, and they are waited to be shifted to India. I mean, you know the situation, but we hope that by October we will have the first 3 prototypes built and ready to work. The other work packages have just started, including like taking the data for the risk assessment, for the social assessment, but also identifying more companies in India which are later commercial stakeholders. Here you have like a really rough overview where we have our pilots installed. The focus will be on Pune, Dhanbad, Aligarh, Kharagpur, and we tried to group a little bit the prototypes in order to have a better monitoring power and also like analytic capacities. Why we are doing this one, I think the water governance and socio-economic issues have been presented also before. Again, we trying to focus on the overexploitation of groundwater resources as one of the like most pressing points right now in India, as most of the people are relying on agriculture to feed themselves, and therefore we have projects where we are actually recharging the groundwater or treated wastewater to the groundwater, or we have pilots where the treated water is used directly for agriculture. Of course, and then all the rest is in some pilots explained, and also most of the pilots are interconnected in order to have like a complete picture. Yeah, I mean, the situation I think in India is really clear, but I see more or less the political will to do something. We have done also like a pre-project on the Indian textile industry, where the zero liquid effluent was actually implemented, and we learned quite a lot, and we are trying to use this results together with our Indian partners to find adapted solutions, especially for rural areas and for smaller settlements. Now just really quick some pilots which are in preparation or already built, or yeah, not finished yet. Here you can see the rainwater harvesting, and we believe this one could be an important point for many Indian cities in order to avoid flooding, but also to have like a better groundwater management. Here we using the rainwater from the roof. It's really simple filtered, and then we recharge the groundwater. And the first tests or the calculations we did is that we are like 3 times faster than any system which is available in India right now. And this system is quite low cost, and we hope that for bigger cities it could be a point to manage more or less the rainwater in a sustainable way. This one is the Sbr system in Aligarh, where we actually take the water from an existing wastewater treatment plant. But I think the treatment capacity is like 25,000 people, and it gets wastewater roughly like 1 million people. That means the water quality of the effluent is really similar to the water quality of the influent. But what is a really good situation for us is that we have some technical infrastructure like a screen, and that we are using more or less a standard water for 3 different prototypes in order also to compare the performance. That means we are quite happy with this location, and we are applying in this location the SBR. I will come also later to the short rotation plantation, and we have an algae pond, which allows us also like to compare the performance. Yes, we have a short rotation plantation system. I think this one has been also explained before. We are using on 1 hectare willow, poplar, and bamboos in order to have like a root treatment system, but also to produce biomass, which we will harvest and use in the project in order to demonstrate potential markets for the biomass produced, and also order to take the farmers with us, because the land we are using is agricultural land, and we would like to have this system running for 20 years. But of course, in order to do so, you need like sellable products, otherwise the farmers are not really convinced. We also have one system which is on the way to India right now for disinfection of river water, or like filtrate, in order to provide safe drinking water. And we have also anaerobic buffer reactor with a horizontal flow constructed wetland. As you can see here, we are like in production right now. We hope that the situation in India gets better in order to finalize the construction work, and to have like the last year or the last 2 years of the project to demonstrate the prototypes and to get the needed results, in order also to convince political stakeholders and participants. Last but not least, we will work with satellite images for our regions in order also to analyze with GIS systems the potential, in order to really give like an estimation which type of technology can solve the wastewater issue in a way. For example, like having like an area with 150 villages, we trying to give like a helping hand for the political decision makers to make an estimated guess what to do and which costs are involved. This was really roughly the presentation for PAVITR. As I said, we are 22 partners in the project. Please visit our website. You find there a detailed description of our objectives, of the partners, and also for the upcoming activities. And if you have any additional questions, please ask us. Thanks a lot for your attention. Hello?
I think we can now pass to the Q&A session. There have been questions published on Q&A.
Nico, we can't hear you. Nico.
I'll try again. Can you hear me now better?
Yeah, it's better.
Okay, so let's start with our Q&A session. There have been quite a lot of questions raised. The first one was somebody saying he was in India many times, and one of the most difficult parts is the contribution from people in helping to achieve zero pollution. How do you address the involvement of people, and how do you get people involved into the management scheme, and how effective this has been achieved? Not only water pollution, but solid waste is a big problem. I would say maybe Anshuman can answer this question.
Sure, I'll try and so this is a very important part. In fact, what we have been suggesting in most of our projects is that the stakeholder consultation be a regular feature, not only during the project of any kind, but also post project. It ensures that the solutions are based on the requirements. It also ensures that the inputs are from the ground, for specific bottlenecks, and also the sustainability of the intervention. So I think that's a very important component for any kind of planning and execution. In terms of how much it has happened, I think the processes have been laid down in various interventions. However, we need to have a policy approach wherein such kind of intervention make sort of a mandatory process, and wherever it is required, I think it should be done in a manner which it makes back and forth feedback and contribution based development of solution. So I think the point is quite important. The solutions have to be coming from within and with the stakeholder participation.
Okay. It was also asked, there is also, of course, a problem with solid waste in India. Is there some kind of analogy with the solving the problem for solid waste?
If I have to answer, I think the solid waste management has been there. I mean, we have solid waste management and handling rules already there. In fact, I think the challenge that at the moment lies is in how to collect the waste. As has been the case for wastewater as well. The collection of solid, segregation of solid is the major challenge. Once it is done, then of course the solid waste handling and storage and treatment is something that has been in the policy and the regulation. I think disposal and storage is something that is as well very important. So this is there, and these programs have been running. In fact, a very important component of solid waste handling is waste to energy program, which is very encouraging, and I think it's forward-looking in terms of how to convert that waste into resource. So there have been examples of how solid waste have been used for resources recovery and energy generation. So I think it's there, and there's an analogy of how we can relate to both water and solid waste.
Okay, thank you, Anshuman. Somebody asked also regarding biogas production, what sources of substrates are you using for biogas production? Is there anybody in the panel who is keen to answer this question? Is there a project working with biogas production?
Well, yeah, we have the Andicos solution, which is actually generating biogas through improving anaerobic digesters. So we are combining concentrated sewage waste with different organic streams. Organic streams could be a primary sludge, or it could be kitchen waste. To actually go back to the first question on solid waste, if we could have a way of separating the waste at the household level and collect it differently, you might be able to organize things like that effectively. But of course, yeah, that's a big challenge to do that in India, as it has been a challenge in Europe. So it's only recently that we have been really sorting out our household waste and making sure that our collection is separated. I think this is the way to go in India as well.
Okay, thank you, Paul. There was also this message from Dr. Sahu from Kolkata. He says to you, Dr. Anshuman, nice to hear you. Under the National Mission for Clean Ganga, for the last 5 years, we have been working in the river Ganga. We saw that in the last 3 years, the water quality has improved. I feel that the National Mission for Clean Ganga is working hard to achieve this with all organizations, including CPCB, CWC, MOEFCC, NEERIA, and IITS. The EU Water Platform is working in the same line. How do you evaluate the progress that the National Mission for Clean Ganga has made, Anshuman, and how do the projects, the India EU Water Project, contribute to that?
Sure. Thank you. I mean, that's a very important question. I think I see a significant change into how the government agencies have been functioning. In fact, NNCG of late has been, very heavily engaged into addressing not only the pollution in Ganga, but also through its program, the general, the general management of the pollution. I for sure, I mean, we work very closely with them, and I am very much aware about the fact that a lot is going into planning, reaching out to people, all kinds of stakeholders, and taking up the interventions in a way that could improve. There have been significant improvement, I have to say, from what it was earlier to what it is now. Although we haven't achieved, as I said in my presentation, what we would have wanted to in terms of clean state of the river, but I think the direction is right and the interventions are right. The ministry is working very hard. The agencies are open to work with various partners and agencies who are able to deliver and have innovative solutions. So I would in a way reflect that they are moving in the right direction. It's just that I think few more integration of aspects would make it much more better, and I think the overall implementation has to be something that we have to focus on. As far as us is concerned, India EU projects is concerned, for example, through our project, as Paul has presented as well, we are focusing on two sites where we are looking at application of technology which can address the aspects of pollution by treating them, not only treating them, but also providing them solution at a low cost, which can be looked upon as a futuristic approach of generating energy or nutrient recovery, and in the process also treating the wastewater. So I think there are these models, and so it's the case with all the projects presented today. And I am aware various other sort of countries and partners and agencies across the world are working towards bringing in the best practices. And I think it's a matter of accumulating those best practices, learning, and trying to see how we can indigenize or sort of develop our own solution framework and implement it effectively. That will bring up the change that we are looking for. Thanks.
Okay, thank you, Anshuman. Another question is, while working on the ground level, are there any inhibitions in terms of cultural and religious sentiments? If yes, to what extent do they affect the work, and what approaches can be taken to work around it? Is there anybody who has experiences with these inhibitions in the project work or in other past projects?
Well, if anybody has to respond, I may just quickly. I mean, working in any regional location, one has to be wary of the local preferences, sentiments, culture. And I think I'm not really saying this from the project that we are handling at the moment, but also from my previous experiences. It's very important that we are in tandem with the local vernacular language, the culture that they have, the people have. It helps both ways. It helps to get in entry and get the buy-in of the stakeholders, but also vice versa, to have that acceptability and sustainability of the solution, which I mentioned earlier. I think I wouldn't say necessarily we always get a bottleneck or inhibition, but there are at times hiccups wherein the alignment is required to get into the nerves of the people. Very quickly, an example, somewhere we were implementing a groundwater recharge pond rejuvenation project, and the locals had their own inhibition about for example, if there is a recharge of pond, there will be a land that will affect their own land holding, or there might be some other impact that they will be brought to. But we had engaged with them. We sort of sensitized them on the issue, and over a period of time, they became the partner in the process. So I think that's the experience that I would share. I don't know if there's anything really inhibiting in the long run as of now. As far as my experience is concerned, it's not.
Okay. Anybody else who wants to add something to this? Apparently not. So the next question, do you think that the implementation of stringent laws controlling industrial pollution and diffuse pollution from agricultural practices will help? Also, if these technologies are successfully developed, how can they be provided to the users? Who wants to answer this question?
I can maybe, can you hear me?
Yes, Mirko.
Yes, Mirko.
Yes, I mean, in our case, as we are using like fast-growing trees to treat the water and to reuse the nutrients, there are already existing structures. You have tree nurseries, and the farmers are quite interesting to see what we get out. I mean, it's not a question of that they have to be convinced. As long as we produce a biomass they can sell, and we have more or less clear targets from them. How much firewood or bamboos we have to produce more or less per year in order to keep the land. And this is something like, I think it's not really a question of if this one works and we actually get the biomass we promise. I think it could be a really good way. In Europe, it would be easy because the farmer would actually get also a share of the wastewater treatment costs. And this would be much, much more than what he gets for the biomass. But in India, this is still an issue that the treatment of water to really give them a specific monetary value is tricky. But I think in the future, if you make a deal and say the farmer makes 50% of his income as a treatment expert, so to say, and 50% of the biomass he can sell freely, then I think the research side can only give a helping hand in what kind of plants have the potential to treat the water efficiently. But I think then it could work really well. I mean, we are quite positive, but we are always.
Okay, thank you. Then there was a question for the LOTUS project. How would those new sensors that Caroline was presenting control the presence of pathogens and contaminants of emerging concern in water before being used in irrigation? Maybe Caroline can explain it again?
Okay, so basically the pathogen detection is an undergoing project. It's undergoing research, but the tier level, like the technology readiness level, is much lower. The reason for this is that LOTUS works well for particles that are chemically characterized, and it's not the case of bacteria. Like either we characterize bacteria one by one, otherwise we need to go around it. So one idea we had at the beginning of the project was to detect caffeine, because anytime you find caffeine in water, it means that you've had the clean water has been contaminated with sewage. The reason for that is that there are so many people drinking tea and coffee that in case like caffeine could be one of them. The problem we had then is that in India, the levels of pollutions are too high and you find caffeine anyway, even though you want the water to be very clean. So we are working on that, but it's not major solution. So we don't have any solution to find pathogen at this stage.
Okay, thank you, Caroline. Another question is, what does the panel think of public awareness programs and awareness programs including the polluting industries into the process? So some kind of governments together with the industries. Who wants to reply to that?
I don't mind talking to that. The public awareness aspect is important, but also it speaks to the previous point about the legislation and legislation enforcement. So getting the industries involved is important, and making sure that the pollution control legislation is enforced is also important. Regarding the technologies, if you don't have public awareness and public buy-in to that, well, then the technologies will never be used. There's no point us doing these projects under those circumstances. So it's one of the key aspects of all of these projects is getting the key stakeholders engaged, involved in the design and in the implementation, and taking responsibility for the implementation and use.
Okay. Then the next question is about the wastewater stabilization ponds in Punjab. Due to the household sewage water stagnating in village ponds, the groundwater is highly contaminated and there are low-cost technologies in resolving the problem. Is anybody who can say something about a solution for this stagnating sewage water from households? Maybe Ruben, we didn't hear you yet. You're also working with groundwater.
Yeah, well, one of the key points in our project is to treat water from industry or even in urban. And the final objective is, so one of them is to use this treated water, for example, to recharge the aquifers and remove the pollution of the groundwater. So I think the use of low-cost technologies can help if we reach the enough quality to use this water as a recharge.
Okay. Anybody of the other people in the panel who wants to say something about this problem? No? Okay, then we move on to the next question. It's a question for Mirko. In your second slide, you mentioned rejuvenation of rivers and restoration of ecosystems. Could you please elaborate on the rejuvenation of rivers?
Can you hear me?
Yes, we can.
Yes.
Yes. I think this one is like it was a general objective of the project, and of course we're taking. I mean, as you can see, we have 50,000 people in 14 prototypes. That means we believe that after we have rolled out the technology, and this is one of the main objectives of the project, then we will have a much lower flow into the river. But to be honest, like really saying that, like to give percentages, how much you can reduce the pollution, I think it is far too early.
Then a final question we received from Vishal.
Nico, we can't hear.
Can you hear me now better?
Yeah, better, yeah.
So a question from Dr. Vishal Vagolikar. What are some examples of incentivizing wastewater treatment for local population and stakeholders? And how do you address the issue of additional cost? Who wants to reply to that?
Well, yeah, okay.
Go on, Paul, I'll let you.
Oh, right, okay, yes. I'm not sure if it's a real solution, but I think one of the key issues is that the pricing for existing fresh water is so low that it's very difficult for wastewater, treated wastewater, to compete with that. So unless you're getting your pricing mechanism right for your surface or groundwater, then it's very difficult to incentivize wastewater reuse. And of course, it's partly a sort of carrot and stick method. So you could actually have you encourage people to use it, and you keep these, maybe you have a subsidy to keep the wastewater treatment down, but at the same time you have a stick method to ensure that if you are trying to control groundwater reuse, groundwater use or surface water use, is that you make sure that the permits and the enforcement of the permits are in place. So it needs to be an integrated approach. You can't just have one incentive. You need to have a whole package of incentives.
Yeah, if I can add one point, I mean, the price of water, I think, is an interesting topic. But even if you look in Europe, I mean, we are working a lot on Germany and Spain, and look how much the farmers pay. They pay nothing. I mean, that's I think to really introduce in India like a payment scheme for agriculture water will be really tricky. We are trying, in the contrary, to make the cost for our systems as low as possible using local people, local resources. And the farmers, for example, are used to pump the groundwater, to channel the groundwater. And we are trying to adapt more or less the same technologies that we actually make a simple table and say, look, you need a pump, you need channels, you have some earthwork, but you get water and you get fertilizer. And like in this way. But of course, it is a tricky issue. I think it would be needed to have a clear legal framework that wastewater has to be collected and treated. And then starting from that, you can actually try to find the most competitive solution or the most adapted solution for each situation.
Yeah.
Okay, thank you. I have one more question for Ruben. You're focusing on high recovery, low cost water treatment systems for saline groundwaters. How do you see the impact of climate change in India on the occurrence of these saline waters?
Yes, well, this question can be answered more or less with the last one I answered, but the climate change is a very important issue in India because of the recurrent drought and overexploitation of aquifers and its pollution. So this is a thing to take into account. But I think with the development of our system, we can deal with the groundwater problems and salinity, recharging these aquifers with high quality treated water.
Okay, maybe another question for Kevin from PANIWATER. There is a trend towards decentralized wastewater treatment and water reuse in Europe. What's the potential for this approach in India, and how will this help to achieve zero pollution?
Oh, it's a good question. I think as it stands, there was a study back in 2016, and they indicated that something like only 38% of households in India were connected to some form of wastewater treatment. That's nationally speaking. So usually in the cities, you're relying on large centralized sewage treatment plants, and with the urban sprawl, it becomes less and less easy to implement that with these large conurbations. So I think decentralized sewage treatment is the way to go. At the moment, you already see lots of farmers taking waters from the canals and the nullas, and they're using that. They're relying on that water quality being good, and we know it's not. We know there are contaminants of emerging concern. So the technologies we've been developing in PANIWATER, the multifunctional reactor and the solar photocatalytic plant, they're specifically designed for decentralized application. Their dimensions are, you could fit them in a garden shed if you had a garden shed. So I think decentralized sewage treatment plants at the small scale really is the focus of where I'm moving towards in PANIWATER. We see that as one of the solutions for it, and hopefully we'll be able to contribute towards that.
Okay, thank you, Kevin. Actually, we have all questions answered now. So we'd like to give the word back to Caroline.
All right. Well, thank you very much for your participation. I'd like to thank all the speakers for their amazing presentations and all the attendants for really tricky questions. So we hope to find you soon. As said at the beginning of the presentation, we will share all the speakers' presentation and the record of these webinars on the project's websites. So it is on the agenda that you will find them. Here you go. Have a very good day.
Thank you.
Thank you. Thank you, Caroline.
Thanks a lot.
Thank you, everyone. Bye.
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 Bye-bye.
Bye-bye. Stay safe.